Hello class, in today's video I am coming to you with problems from 2.2, section 2.2 for statistics. I'm going to share my screen and get started right in the content. Again, when I'm working these problems, I'm choosing problems where you have to either do maybe a long process, a formula, if you go about it the long way. So I'm choosing these problems to show you how you could alleviate your work time and do them on the calculator. So I'm not working all of the homework problems, just select ones that I know you could benefit from the technology. Okay, so let's see here. Let's jump right in. Okay, so this is again from 2.2, and in 2.2 we're focusing on linear regression. So this first problem that I'm looking at, we are given a set of data, ordered pairs, where X is represented by calories and your Y values represent sodium levels. So it says find the equation of the regression line for the given data, then construct a scatter plot of the data and draw the regression line. Each pair of variables has a significant correlation. So in other words, they make that statement so that you're aware that the linear regression, or the line of best fit is another way of calling it, the linear regression or the regression line is relevant. Okay, so it has correlation, so therefore a regression line will be relevant for this data, because if it didn't have correlation there would really be no point. Okay, so moving on, it says then use the regression equation to predict the value of y for each of the given x values if meaningful. The caloric content and the sodium content in milligrams for 6 beef hot dogs are shown in the table below. All right, so our x values are given, and then right below that we have our y values. Okay, so what I'm going to do is show you how we can alleviate the need for those long formulas, because if you're working the homework and the homework problems and you click on help me solve this, or you click on view an example, they're going to show you the long way of getting this. Okay, I'm showing you how you use the technology. And then we also have calculator tutorial videos embedded as well, but that's a separate, I don't really want to call it an assignment, but it's a separate, it's a separate assignment that you would need to click on. It's not actually within the homework itself, but every module does have a calculator tutorial video, but this will help you tremendously. So I'm going to actually work these problems, okay? Whereas the calculator tutorial may show you something similar to it, but not exactly the same problem. Okay, so the first thing we're going to do is we're going to put our data into a list, okay? And by default, your X value should go in list 1 and your Y value should go in list 2. Your calculator is kind of already programmed for that manner, so just stick with that trend. So I'm going to put X values in list 1 and I'm going to put the Y values in list 2. Now, how do I pull up the list? Remember, we talked about this in 2.1. We only use one list in 2.1. Now we're going to use two lists, but how you find the list is still the same. You will press the stat key, okay? And I'll try to scoot up my calculator as much as I can without covering up information that I may need. So you press the stat key, and edit is already highlighted, and that's what you want to do. So you just press enter. And because I already have some stuff in the list from a previous problem, I'm going to go up to the list name and I'm going to press clear, enter. Okay, not delete. Be careful, you don't want to press delete, because if you press delete, that means you're deleting the entire list. And we would have to reset your calculator, just go through a little headache of stuff to get it back, because you have to have list 1 in your calculator. Okay, so in list 1 I'm going to put in 150, 180, 130, 120, 70, and 190. And you want to make sure that you've got all 1, 2, 3, 4, 5, 6 values in. And we do, because you can see how the calculator is waiting on value number 7, if we had a value 7. Let me zoom in a little bit more. This light on my screen is kind of giving me the blues here. See if I can adjust that a bit. Don't know if I'm helping it. So it's not really helping. I'm going to have to scoot it out of that light. I think that's what I'm going to have to do. Yeah. See if I turn it off. Yeah, I still have a glow. Okay. So yeah, I'll just move it about out of the light a bit. And like I said, when I need to show you my keypad, I'll just have to scoot it up and then scoot it back down. All right, so let's go over here and put the Y values in list 2. So we got 270 and the last one 550. Okay, we got our values entered in. Now we're actually ready to calculate. Okay, so you're gonna press that and you're ready to analyze the data. So you're gonna arrow over to calculate or calc. And this time, notice the wording. We're looking for the regression line. Look at number 4, LIN, short for line, REG, line regression. Okay? Doesn't get any plainer than that. Now, if you are fresh out of high school, or if you recall from high school or some algebra class, you might remember that we typically call slope M, like y equals mx plus b. Well, your technology calls the slope A, but this is still the same format that your equation will be set up in. You got your y equals blank x plus blank. That's where your m goes, or your a value goes. Y equals ax plus b, where a is your slope and b is your y-intercept. Okay? So we're going to go down to number 4. We're going to select it by pressing enter. And you notice that right here by default, it says X list is L1 and Y list is L2. The frequency list, you don't have a frequency list. That should be empty. You don't have a stored regression equation. So you're just going to arrow down to calculate. Now, if you've got a TI-83, you won't see this on your screen. It will take you directly to your home screen, and then you'll just press enter. Like, it'll put this right here that's highlighted in black, it'll put that on your home screen, and it'll wait for your command, which at that point you can just press enter and then enter again, because your calculator will, by default, just like this one did, by default, it will automatically use L1 for X list and L2 for the Y list. Okay, so we're going to hit calculate. And so our slope is 2.104 and our y-intercept is 105.41667. Now it says to round to 3 decimals. So this 2.104 and to the 4 is 3 decimals. So 2.104, that's going in front of the x. And our y-intercept is 105.417, rounding that to 3 places as well. Okay? Now, this is the part that you would really need to be on the computer to see very clearly. When I print this, the pictures, they're not perfect. I will say this, though. Your slope will indicate what direction your linear regression line would be in, or where your points would actually kind of be, the line that your points would be following along. You have a positive slope, so your line should be going upward. So that means B and D, you can eliminate those as choices. We know those cannot be correct, because notice that the regression line here is going down, which would indicate a negative slope, and we can see that our slope is positive. So B and D cannot be correct, okay? So we would need to make a decision between A and C. Now, if you want to see the graph of this, what you see here on display on your calculator, you can. What I will do is have the calculator to graph the list that we put in, and I will have it to graph the equation. I'm going to put the equation in the calculator, okay? So how do I do that? Look at this calculator right here. You see how you got y equals in this upper left corner? Okay, that's where you're going to put in this y equals equation. And then you also can see here where I've got stat plot written right up above the y equals key. That is what you'll turn on to graph the points. Your stat plot, you're graphing your plotted points. Okay, so the first thing I'll do is I'll put the equation in. So I'm going to press y equals, and I've got some stuff already in there, so I need to clear that. Notice I just pressed clear, okay? And then I'll go down and press clear for that as well. So right here, I'm going to put y equals in that first one. It doesn't matter, but that's the one I'm going to use. And again, I've got this glare. It's just not cooperating. Maybe that's a little better. Okay, so I've got 2.104. Now this x right here, you see how it's xt theta n? That's what you're going to use for x. Okay, that's the key that you will use for your variable x. It's the xt theta n key. It's your unknown variable key. Okay, or your dependent variable key. And then we've got plus 105.417. Okay. All right, so I've got that entered in. Now I want to turn on my stat plot. So you see how that's written in blue? That means it's the second function of this key. So I'm going to press second y equals for stat plots. And I've got several, but I'm just using that first one because, it's the first one. And this is, what we typically use. So I'm going to select it by pressing enter because right now it's highlighted. I'm going to press enter. And I'm going to turn it on, okay? Now, I press enter while on is flashing. I press enter and now it's on. Now I just want to make sure that it's the correct type of graph because there's a particular graph that we've got here that we're choosing between, and it is a stat plot graph. So it's a bunch of single points. So that first graph is the one I want to select. And notice by default, my X list is L1, my Y list is L2. I don't have to change any of that. Okay, so it's on and the type that I want is already selected. If it hadn't been, I would put my arrow on it where it would be flashing and I would press enter to select it. Okay, now I'm going to press graph. And it's probably likely that you have the standard graph window. Here's the graph key. When I pressed it, it gave me the standard 10 by 10 window. And notice that I don't see anything. That's because this window is too small. I mean, take a look at your y-intercept here. It's 105. So I naturally can't see that on here, and these points, look at your points. If this is a 10 by 10 window, my points are well beyond the scope of 10 by 10. We're talking the 400s, 300s, 200s, okay? So what I'm going to do in order to adjust my window, I don't want to do it manually. I'm going to let the calculator figure it out for me. I'm going to press zoom, and I'm going to scroll down or arrow down to either zoom stat or zoom fit. Me personally, I prefer zoom stat, but they both should work. But since we're in statistics, I usually use the zoom stat because it'll mode my calculator to fit this data. Zoom stat. I'm going to press enter there. And look, there it is. Now, how do I still, looking at this paper, can I still, or even if we were on the calculator, how do I know for sure that I'm choosing the right graph when I don't have any numbers present to know where these dots are? Do this. Look at the line and count how many points you have below the line and how many you see above it. And just notice which one matches that, okay? Because one of them will and one of them will not, okay? So I'm looking at this one, and I'm pretty much going to throw it out because that top point isn't on the line, and you can see how on A it shows that it's on it. The one that is actually touching it, let's see here. Also, another indicator I've got on A is that these 2 points are kind of like directly across from each other, and I don't have that. I have a lower point, and then I have these two that are more closely or kind of more across from each other. And then I have that point that's touching it, and then this point. So I would say C would be the answer there, okay? But again, this graph is harder to read on paper. When you're on your computer, you'll be able to see it much easier, and you'll be able to tell without a doubt which one is the correct graph, okay? So how did I graph it? I turned on my stat plot so that it would graph the points, and I put the equation in my y equals, okay? Now, after we do that, it then wants us to predict the value of y given some x values, okay? So given that x is 170 for part A, 100 for part B, 140 for part C, and 220 for part D, we want to predict the value of y for each of the given x values if the given x value is meaningful. Now, what does that mean? Okay, if meaningful means if it is within the scope or within the range of the given x values that you have already. So in other words, if I'm given this outrageous x value that falls well beyond the scope or the range of my given x values, then I cannot say for sure that this would be a good prediction equation for that particular value. So if I have, look, my lowest value for x is 70, and my highest value for x is 190. As long as the given x values that I want to predict for, as long as those values are somewhere between 70 and 190, then this is a good prediction equation for those points. But if I was to be given a value that is beyond 70 to 190, then I can't say for certain that this would be a good prediction equation for that value. Like part D, for example, its value for x is 220. 220 is beyond the range of values that I'm given on x. So I can't say that this would be a good prediction equation for that value. So I can't say that it would be meaningful. Even though I could calculate it, I can't say that it would be meaningful. Okay? So for part A, we want to predict the value of y given that x is 170. 170 is within the range of 70 to 190. Remember, 70 is your smallest value, 190 is your biggest. 170 does lie within that range. So I can predict for x equals 170. So I would have y equals 2.104x plus 105.417. And where I have x, I'm going to replace it with 170. So I have 2.104 times 170 plus 105.417. Okay? So 2.104 times 170 plus 105.417. I get 463.097. I get B for my answer. Okay? Then I'm going to predict for B, x equals 100. So I have y equals 2.104 times 100 plus 105.417. So I have 2.104 times 100 plus 105.417. So I get 315.817. Okay, which would be A. For part C, I want to predict when x equals 140. So y equals 2.104 times 140 plus 105.417. 2.104 times 140 plus 105.417. I get 399.977. B. And then lastly, 220 is outside the given range of x values. So therefore, we would say that that is not meaningful. And it looks like, let me scoot that up, I'm sorry. It looks like it got cut off there at the bottom, but that would be not meaningful. My problem got cut off there. Yes, it is. It's on the other side right here where you can see that answer there got cut off. That would be D, not meaningful, for part D. Okay, not meaningful. All right, so that was the first one in 2.2 that I wanted to look at. Let's see if I got another one here. believe I got one more of this type that I wanted to talk about, and then we'll look at something else. All right. This is another problem similar to that. And mainly, I just want to show you again how we put it in the calculator, okay? Just to be sure that we're okay here, because it's still the same type of problem. So I may not answer the parts A, B, C, and D completely, but I'll just kind of talk about them. So for number 7, it says the accompanying data are the number of wins and the earned run averages, mean number of earned runs allowed per 9 innings pitched for 8 baseball pitchers in a recent season. Find the equation of the regression line. Then construct a scatter plot of the data and draw the regression line. Then use the regression equation to predict the value of y for each of the given x values, if meaningful. Okay? If the x value is not meaningful, explain why not. And that was what I did on the previous problem when it's outside of the range, okay, of the given x values. All right, so number 7, I think the table populates on another page. Yeah, here it is right here for number 7, the table. So I'm going to scoot that page back for just a minute so I can put my data in. Okay, so we're going to press Stat. Edit is highlighted. We're going to press Enter to edit. We're going to go up to the list name and press Clear, Enter. We're going to go up to this list name and press Clear, Enter. So again, all I did was arrow up. Okay, let me scroll up here, scoot up here so you can see. I arrowed up to the name. I pressed Clear, and then I pressed the Enter key to clear it out. Okay? Don't ever press Delete. Here's Delete. You want to use the Clear button. Okay, so in list 1, I'll put 20, 18, 17, 16, 14, 12, 11, 9. And then in list 2, I put 2.81, 3.37, 2.69, 3.65, 3.77, 4.24, 3.79, 5.07. Okay? All right, so now I'm going to go back here to my first page for number 7. And now I'm ready to get my regression line. Okay? So here we go. All right, after I put the data in, then I press Stat and I go over to Calc, and I want to use number 4, linear regression. Okay? Number 4. I press Enter. And remember, by default, list 1 is the x values, which is why we made sure we put the x values in list 1. And list 2 is the y values. You don't have a frequency list, you just arrow down to calculate and you press Enter. This time my slope is negative, and also they want me to round this time to only 2 decimal places. So this is my slope is negative 0.18 when I round that to 2 decimals. And of course the 0 is in front of the decimal, I just didn't read it. So negative 0.18 or negative 0.18. I'm going to put the 0 there, 0.18. Okay? Then my y-intercept, I'm going to also round to 2 decimals. That will be 6.29. Okay? Excuse me. Okay, now I'm ready to see the graph. Excuse me. Okay. So I've got the data in the graph already, or in the calculator already. Now I need to put the equation in the calculator. So I'm going to press y equals. And right here, I'm going to clear that because that's what we had before. And I'm going to put in negative 0.18 or negative 0.18, however you want to do it, x plus 6.29. Okay? My stat plot for 1 is already on because we had it on before. So you're good to go there, but if you want to double check it, you press second y equals to check the stat plot, and we can see that it's on, and we can see that the graph that we're going to graph, or the graph that's selected or chosen, is the scatter plot, and it's using list 1 and list 2, okay? And so now I'm going to hit graph. And again, my window is fitted to the data that we had previously. So I need to adjust that window, and I'm going to adjust it the exact same way that I did when it was the standard window. I'm going to press zoom, and I'm going to go to zoom stat. You can see that the line or the dots are actually falling or decreasing, okay, going down because our slope was negative, okay? So 2 of them you can automatically just throw out, okay? First of all, A, because these are line segments connecting the points, and that's not what a regression line does. A regression line is also known as the best line of fit, okay? It does not mean every point will be on the line. It just means it is the best line of fit that is as close to every point as possible, okay? So A would be thrown out, and C would be thrown out as well, because C is a horizontal line, and the only way you would ever get a horizontal line is if you had a zero slope, and we don't have a zero slope. Yes, our slope is small, but we do still have a slope, okay? So it has to be either B or D, and we just want to try to choose between the two. And again, if you were on the calculator, not on the calculator, if you were on the computer comparing the computer graph to the calculator, it would be much easier to, to choose or to see the difference in the two. On paper here, they look really similar. But I do notice one slight difference here. That top point is at the top or above the line here on D, and it's below the line here on B. But notice on our calculator, it's above. So the answer has to be D. And that's kind of what you can just use, process of elimination, okay? Notice what is different about the two graphs and play a matching game to yours on the calculator, okay? All right, after that, then you're ready to predict the values for y when given certain x values. To me, this is the easier part. As long as this equation is right, you should be good on these. But guess what? If this is wrong, then all of these will be wrong as well, okay? Because again, your prediction equation is what you're using to predict for these, okay? So for part A, it says predict the error for 5 wins, okay? Now, you want, and it says if meaningful, you want to ensure that the value you're predicting for actually falls within your range of given x values, because if it doesn't, then you would say that that prediction value would be not meaningful. So your x values range from 9 is the smallest to 20. Well, 5 is well outside of that range. 5 is way smaller than 9. So I can't say that this value that I would get would be a good prediction for 5. Okay, so this is not a good prediction equation for x equals 5. So I'm going to say, let's read B and C. B says it is not meaningful to predict this value of y because x equals 5 is well outside the range of the original data. That is the correct answer, okay? It does not have to be an exact value given in the original data. It just has to be within the range of the given data, okay? So that's why B is the correct answer and not C. C says it is not meaningful to predict the value of y because x is not an x value in the original data. It doesn't have to be, okay? It doesn't have to be an original x value. It just has to be within the range, okay? And because it was not within the range, then it is not meaningful to predict for that value, okay? B is 10, okay? It would be meaningful because, again, our range of values ranged from 9 to 20. Our x values range from 9 to 20. So we can predict when we let x be 10. So we're letting x equal 10, and we're going to plug in 10 into this equation that we found above. So where we have x, we're going to replace that with 10. Okay? So we've got negative 0.18 times 10. Let me scoot my calculator over. Negative 0.18 times 10 plus 6.29, and we get 4.49. And if you wanted to show the decimal, or the 0 in that first decimal place, or in front of the decimal, the 0, you can. It's not a big deal whether you do or not, okay? And then you would still get the same answer, okay? So y would be, when x is 10, y would be 4.49. I'm going to do one more here, part C. It says predict the ERA for 19 wins. So here we're letting x be 19. So we'd have y equals negative 0.18x plus 6.29. And that x would become 19 plus 6.29. So we would have negative 0.18 times 19 plus 6.29. We would get 2.87. Okay? All right, that's all I have for that problem. Let me see if there's anything else that I wanted to talk about from 2.2. That was the main thing. I wanted to be sure that I talked about calculator things. There are a couple of problems at the end of 2.2 where you're introduced to probability, because in Module 3, we focus on probability. So we get a slight introduction to it, some basics in 2.2, and then we go full steam ahead in Module 3 with probability. So this problem, number 10 in 2.2, is asking you about the sample space for a probability experiment. So I did kind of want to just make sure I explained this well to you so that you understood it. A sample space is just basically the whole set of possible outcomes, okay? It's all of the possible outcomes that could happen or could occur or you could get for a probability experiment. So let's look at this experiment. The experiment is randomly choosing a number from the even numbers between 10 and 20 inclusive. So inclusive, first of all, means including 10 and 20. So we're going to list all of the even numbers between 10 and 20. Okay, 10 and 20. So 10, 12, 14, 16, 18, 20. Those are all of the even numbers within or between 10 and 20, including 10 and 20. So the sample space would be this whole set, the set of all of the numbers that satisfy this experiment. So you would actually just list them here, separating them by commas. And of course, I'm out of room here, but when you type, you'll have more room. And so given that this is the sample space, you are then to just count the number of outcomes for this sample space, and there are 1, 2, 3, 4, 5, 6 of them. Okay? So the sample space is simply the entire population or the entire set that would exist for a given probability experiment. Okay? And like I said, we look at probability in detail in the next section. All right. One more problem in 2.2 that I did want to talk about, and it is finding the correlation coefficient. So the main part of this section is linear regression and correlation coefficient. So in order for a linear regression or in order for a line regression or a regression line to even exist, you would first have to know that your data is correlated. And the way that you determine if your data is correlated is by calculating the correlation coefficient. So sometimes you'll be told up front that the data is correlated, and sometimes you'll be asked to actually find the correlation coefficient, okay? This correlation coefficient is called R, and you'll read about this in your lecture videos. You'll listen to the lecture videos and hear about this. But there is a formula for how you can calculate it, but of course, it's kind of lengthy, and I want to show you how the calculator can find R for you, okay? Now, if you recall just what we were just doing, we were putting the X values and the Y values in lists. We're going to do the exact same thing again. Put the X values in list 1, put the Y values in list 2. And we're going to still be using the line, REG, AX plus B. The difference is, though, I have to ensure that I turn on this diagnostic in order for it to get, in order for this, the line regression, in order for it to give me the value of R, okay? So I want you to notice something from before. Let me turn my calculator back on. This is a previous problem, just looking at what we just calculated, okay? Remember this is what we're going to be using, linear regression, AX plus B, where the X values are in list 1, the Y values are in list 2, and you go down to calculate. And it gave us A and B. Well, if I turn on another key on my calculator, then it will actually also give me R. It's supposed to show me the value of R as well. It's not on right now, but it's about to be. So let me show you something. So on your calculator, here's what I want you to do. I'm going to scoop my key up, or scoop my calculator up so you can see my keys here. You see this word catalog in blue? Now on your calculator, if you have an 83 model, yours may be gold, but it is the second function of the 0 key. What I'm going to do is press the second button and then 0, and it pulls up the catalog, which is just a list of all of the operations on this calculator. I'm going to scroll down because it's in alphabetical order. I'm going to scroll down until I see diagnostic on, because I'm going to see diagnostic off and I'm going to see diagnostic on. I want to turn it on, okay? And I'm getting into the D's now. Should be getting close. Okay, here we go. And I just passed it right here. So you see diagnostic off, diagnostic on. I've got my little cursor selected at diagnostic on. I'm going to press enter. Okay, and it put that on my home screen. I'm going to press enter again so that it's on. And it says done now. Okay, now let's press stat now. And let's edit these values into the calculator. And I'm going to press enter to edit. Remember, this data is from the previous problem, so I'm going to go up to the list and press clear, enter. I'm going to go up to the list and press clear, enter. So in list 1, I'm putting in X. I got 70, 83, 89, 88, 86, 96, 73, 98, 78. And then in list 2, I've got negative 2, 2, 5, 5, 3, 10, negative 1, 10, 0. Okay? After I enter my data in, I press stat again, and I'm ready to calculate. So I go over to calc, and I'm using number 4 again, okay? Because remember, correlation and regression are related. So we're using that same linear regression key. So I'm going to go down to number 4. It automatically has my X list stored as list 1 and my Y list stored as list 2. So I'm going to go down to calculate. I'm going to press enter. And look, now I see R. I also see R squared, but don't be concerned with that. You're focused on R, okay? R squared is some other value that I'm not sure if it's talked about much at all in this class, but R is the value that you're interested in. R is your correlation coefficient. And notice how close it is to 1. That means there is a strong positive linear correlation. If it had been really close to negative 1, then we would have said there is a strong negative linear correlation. But this is positive. This is a positive value, and it's really close to 1. And that answer would be D. And that just simply means there is a strong positive linear correlation. The closer it is to 1. The closer it is to 0, the weaker the correlation gets. Okay? All right. That is all I have for this section. See you soon.